Hello everyone, welcome to the video lecture on single phase energy meter. So in today's lecture we would see the following contents: energy meters, introduction, construction of single phase energy meter. Under construction we will see about the driving system, moving system, braking system, registering system, and what is the working principle of single phase energy meter and questions. So coming to the introduction of energy meter, we all know induction type of energy meters are universally used for measuring energy both in domestic and industrial AC circuits. Induction type meters possesses low friction and high torque weight ratio. Induction type meters are inexpensive and accurate, and they have accuracy over wide range of loads and at different temperature conditions. So energy is calculated as power delivered or consumed over a time period, and it is given by power into time. So energy developed is a work or dissipated as heat over an interval of time, and it is expressed as in the following integration: W is equal to integral of 0 to t Vi dt. So where W stands for the amount of energy consumed, V is expressed in volts, voltage is expressed in volts, current is expressed in amperes, and time period is expressed in seconds, and the unit of energy is joule or watt second, which is 1 watt over a interval of 1 cycle or 1 second. If the unit of time is taken as hour, then energy is expressed in watt hours. So in many instances, because of the inconvenient size in the unit, we measure energy in larger units, and we say as kilowatt hour, where kilowatt hour is nothing but energy consumed or the power delivered at an average rate of 1000 watts per hour. So this is all about the introduction of how we can calculate energy. So now coming to the construction of energy meter. So the system that you are seeing is a single phase energy meter. So the components of the system has two silicon steel laminated electromagnets. So we can see the upper magnet is a shunt magnet, and it has many turns of thin wire, and the lower magnet is a series magnet with two current coils and a few turns of thick wire. Current coils are connected in series with the circuit, and it passes load across it. The voltage coil is connected to the supply to produce high ratio of inductance and resistance. So we can see this pressure coil will be connected to the supply, and the current coil will be connected in series with the load. So driving system basically has two magnets, two electromagnets, which is a shunt magnet and also a series magnet. So the coil of one of the electromagnet is excited by load current and is called current coil. And the coil of second electromagnet is connected across the supply, and the current produced is proportional to the voltage, and it is called as pressure coil. So driving system consists of two electromagnets, series and shunt magnets. And apart from these two magnets, we have copper shading bands. So we can see in the figure we have copper shading bands, and these copper shading bands provides a frictional compensation so that the angle between the flux produced by the magnet and the supply voltage is 90 degree. So copper shading bands are provided on central limbs, and they are adjustable. So the reason for providing these copper shading bands is they produce a flux between the shunt magnet with respect to the supply voltage, and the angle between the flux and the supply voltage will be 90 degrees. So this is all about the driving system. Now coming to the moving system. So the moving system is nothing but the aluminum disc which is placed in between the two electromagnets, that is the shunt magnet and the series magnet. So we know shunt magnet is connected to the pressure coil, and series magnet is connected to the current coil. So in between the two coils or two magnets, we have an aluminum disc, and that is the moving system. So the eddy currents are induced in the aluminum disc, which cuts the flux produced by the magnets. As a result, the interference of eddy currents of two magnetic field produces a deflecting torque on the disc. So we know pressure coil produces a magnetic field, and similarly current coil also produces a magnetic field. So because of these two magnetic field, a torque is produced, and because of the torque, the aluminum disc slowly rotates, and after several rotations we consider it as power consumption, or the measurement of energy, and it is measured in kilowatt hour. So the moving system basically consists of an aluminum disc which is mounted on a light alloy shaft. So the disc is positioned between series and shunt magnets. The upper bearing of the moving system is a steel pin located in a hole in the bearing cup fixed to the top of the shaft. So this aluminum the aluminum disc at the top is connected to the steel pin, and this moving system runs on a hardened steel pivot. So the moving system is made up of a steel pivot, and this pivot is supported by a jewel bearing, and this engages the shaft to count or read the number of units. The suspension of this disc is placed in the floating shaft energy meter. So here the rotating shaft is a small magnet at each end, where the upper magnet of the shaft is attracted to the magnet in the upper bearing, and the lower magnet of the shaft is attached to the lower bearing. So moving system is basically the aluminum disc, and this aluminum disc is placed between the two electromagnets, and because of eddy currents, magnetic field is produced between the two electromagnets, which makes which forms a driving torque, and this driving torque makes the aluminum disc to rotate. So this aluminum disc is basically a steel material which is properly mounted on jewel bearing, and it is properly screwed so that it does not fall down. And this is all about the moving system of energy meter. Next, coming to the braking system of energy meter. So the braking system is the main part of an energy meter, and it is located near the aluminum disc, so that the eddy currents are induced in it due to the movement of rotating disc through the magnetic field. So which causes the eddy current is, it is nothing but the braking magnet. So braking magnet produces the braking magnet induces the eddy current, so which makes the aluminum disc to rotate. The eddy current reacts with the flux and exerts a braking torque which opposes the motion of the changing flux. So any change in the flux is opposed by the braking torque. A permanent magnet positioned near the edge of the aluminum disc forms the braking system. So we can see in the diagram a permanent magnet, which is an U-shaped structure near the edge, forms the braking system. So this braking system provides an eddy current which is opposite to the motion of the magnetic flux produced. The aluminum disc moves in the field of the magnet and provides braking torque. In braking system, the permanent magnet can be adjusted so that the braking torque can be adjusted. So next, finally, we have the registering system. So the registering system registers the number of rotations of the disc, and it is proportional to the energy consumed. So there is a disc spindle which is driven by a gear, and indicates the number of times the disc has been rotated. So the functioning of registering or counting mechanism is to record continuously the number of times the disc has rotated, and it is proportional to the number of revolutions made by the moving system. So by a suitable system, a train of reduction gears, the shaft drives a series of 5 to 6 pointers. They rotate on the round dials which are marked with divisions. So we can see we have round dial which has several divisions, and after each division the energy is noted for every revolution. So next we'll see how the energy meter works. So the energy meter working is based on two principles: rotation of aluminum disc and arrangement of counting and displaying the amount of energy consumed. So rotation of aluminum disc, we already know we have two coils, pressure coil and current coil. So pressure coil produces a magnetic field that is proportional to the voltage, and current coil produces uh, magnetic field which is proportional to the current. So because of these two magnetic fields, the aluminum disc will move. So we can see this is the aluminum disc which rotates when the voltage and current is consumed. The rotation of metallic disc is operated by two coils. The coils are arranged in such a way that they produce magnetic field, and it is proportional to the voltage, and the other coil is proportional to the current. The field produced by the voltage coil is delayed by an angle of 90 degrees so that the eddy current is induced in the coil. So next, because of the two fields, we know a force is produced, and this force makes the aluminum disc, light aluminum disc, to rotate in the air gap. But there is no need to stop the disc when there is no power supply. A permanent magnet works as a brake which opposes the rotation with respect to the voltage consumption. So we saw a permanent magnet which is kept near the edge of the rotating system to provide the braking torque. Arrangement of counting and displaying is determined by the number of revolutions made by this rotating disc. Okay, so this is connected to, so we can see this is rotating disc is connected to a window, as a window kind of display. The aluminum disc is connected to a spindle which has a gear. So this gear drives the register, and the revolution of the disc is counted and displayed on the register, which has series of dials, and each dial represents a single digit. So each dial represents a single digit. So there is a copper shading ring at the center limb of the shunt magnet. So the phase angle between the flux and the shunt magnet is such that it is 90 degrees, so that small adjustments can be made. So this particular energy meter is widely used in all domestic and industrial AC circuits because they have low friction and high torque per weight ratio. Also they are very inexpensive, and it maintains a high accuracy of reading.